The question I choose to talk about is 6P.107. A pendulum consists of a very light but steep rod of length L hanging from a nearly frictionless axle with a mass m at the end of the rod. A. Calculate the gravitational potential energy as a function of the angle theta measured from the vertical. We can first write down the formula for potential energy, which is U equals to mgy, and we can see from the graph here that the y can be calculated by L minus L multiplied with cosine theta. So when we apply this in the formula, we can have U equals to mgl multiplied with 1 minus cosine theta. B. Sketch the potential energy as a function of the angle theta for angles from minus 210 degrees to 210 degrees. Okay, we can first make the potential energy the y-axis of the graph and the theta the x-axis of the graph. And when the theta equals to 0, which means the pendulum is at its original position, the potential energy is 0. And when the theta equals to minus and plus 118 degrees, the potential energy is at its maximum point. So at either side of the maximum point, the potential energy will only decrease. So we can have the graph here. C. Let S equals to L theta, the arc length away from the bottom of the arc. Calculate the tangential component of the force on the mass by taking the negative gradient of the energy with respect to S. Does the result make sense? Okay, we can have the F tangential here, which equals to mg times the sine theta. D. Suppose that you hit the stationary hanging mass so it has an initial speed vi. What is the minimum initial speed needed for the pendulum to go over the top, which is theta equals to 180 degrees? On your sketch of the potential energy part B, draw and label energy levels for the case in which the initial speed is less than, equal to, or greater than the critical initial speed. Okay, we can see from the energy conservation principle that the initial energy must equal to the final energy. So initial kinetic energy plus initial potential energy must equals to final kinetic energy plus final potential energy. So we can write it down, and we can write the formula, detailed formula down here. So we can solve for V equals to 2 multiply with square GL. Okay, and we can see from the graph in part B here that when theta equals to 0, when potential energy is the smallest, which is also 0, the speed is equals to its initial speed and its maximum speed. And when the potential energy reaches the highest point, the speed equals to 0. During the whole process, the speed is decreasing.